Hi, and welcome to Tech Takeaways. I'm your host, Jason Fitzgerald, and I'm joined as ever by my dynamic co-host, Paul Stringfellow.
I am indeed dynamic. That's so much better than the one you did last week.
Thank you very much.
Although you missed out all the little bits about my favourite bit where you slice it into small bites for people.
I've had a week to reflect on that intro, and I feel more comfortable with this.
I know we've had a week to reflect on it, but we've not got around to changing our clothes since last week. So, it's almost like we record all these in one go. Who knew?
Well, and this week we welcome back Peter Goodwin from Efficient IT. Welcome back.
Hi, Jason.
Welcome back.
Cool.
So,
and Peter's been sat in that chair for a week as well.
Good to have
again,
you back.
hasn't changed.
Yeah.
Hasn't changed his clothes. I mean,
Busy life.
Who knew?
It's ripe in here.
Who knew? So
I feel we've digressed. Sorry.
Yeah. So this week's episode, I think we want to expand on where we went with last week's episode around DDI, so DNS, DHCP, and IP address management, and we started to get into, when we were discussing the visibility elements of it, how that can help with cybersecurity, and that's really something that we want to delve into a little bit more in this episode, really, to kind of explore. Okay, so we've got a DDI platform, we've got some DNS, DHCP, and IP address management. We've got some increased visibility on that. Let's really focus in on the cybersecurity element of it and see where we end up with.
I think so. It's we talked about this before. I think it's become one of my favourite topics. And actually, we talked a little bit before we recorded about DNS security gives you an awful lot of bang for your buck. It's something that can be done that's relatively, it's a low risk deployment, doesn't have to be particularly expensive to do. And the value that you get from that investment can be huge. But that's why Peter's here to tell us why all that's true, as opposed to just me rambling on about it.
Well, for me, the reason why I like seeing security wrapped in those critical network services is that they fly under the radar. They are taken as a granted. It's the first thing that happens to most devices when they join a network. They join a network, they get a DHCP IP address. Okay, great. That happens on a home router and it happens in a corporate network in pretty much the same way. But if we can start to add some visibility and security into that, that's a game changer.
Yep.
Because that is now where we're validating what's on the network and where that goes. So for me, these are really, really powerful technologies to start to integrate some security. And so we were talking on the previous episode around visibility versus using Excel spreadsheet. I think that's probably a good place to start with this. Would you agree?
I mean, just everyone uses spreadsheets before they go commercial for their IP address management.
Yeah.
Before they get big enough to actually need a more commercial offering. And they probably use Microsoft Active Directory, DNS, and DHCP because it comes with AD and it's essentially for free. And you can do some security checks with the Microsoft DNS server. You can run threat data, or response policy zones is the DNS name for them. But you can load threat data on and you can check each query against a list of known actors. You can do that on the Microsoft platform. What you can't do is the more sophisticated behavioral kind of stuff with DNS, where you need to start looking at individual clients and what they're doing.
Okay.
And DNS, it's based on UDP, so it's essentially fire and forget. The protocol itself has a lot of redundancy built in. So if a client doesn't get a response after shouting into the void, can you give me www.google.com, it will make a number of attempts. And it's normally 5 attempts. So you'll notice it on a browser. If you don't have DNS, it's about 15 seconds before you get the failure, because there's 5 queries going off before it decides, I give up. And you normally get 2 DNS servers when you start, and it will go 1, 2, 1, 2, 1. Okay, I give up if it can't resolve. So it does have some built-in kind of things to help you along the way. But the Microsoft solution, open source solutions, don't really start to look at what individual clients are doing, because to do that, you've got to look at keeping a little bit of state history on what the individual clients have done. But if you do start doing that, you can look at what individuals are doing with DNS. And there's one of those things where I think there's a statistic about 91% of malware uses DNS at some point in its life cycle. Typically for exfiltrating data or infiltrating the payload after it's done an initial infection, or just to talk to a command and control system. That normally happens today over DNS because all the firewalls let DNS traffic go through. Yeah. Otherwise, we can't resolve anything.
And I think that's quite important, and I don't think a lot of people recognize this. DNS is so fundamental on networks that it's pretty much allowed out. Because that's how the internet works. You get off the network and you get onto the internet because DNS works. But actually, we're seeing more and more malware using the DNS protocol and port to literally exfiltrate file data out of organizations. Are you guys seeing that as well?
Oh, yeah.
Right,
yeah.
Okay.
It's one of the things people don't really look at what DNS is doing if it's working.
Yes.
When it goes wrong...
It's always DNS.
All hands to the pumps. What's going on? Yeah, there is that thing. A lot of people think it's always DNS. Not always, but quite a lot of the time.
Yeah.
But we should start to think about looking at what is going on in the normal DNS that works. The challenge is there's just so much data. There's a metric that we use that if you want to know how many queries per second a bunch of people make, it's how many are there. Just divide it by 5. Smart devices, laptops normally make about 0.2 query per second per person or per device. So you just take up the number of clients, divide by 5, gives you a rough idea of what the query per second rate is going to be every second. It's an immense amount of data to search through. So no one does it until something goes wrong, and then forensically, if they've done or they've kept logs, and it's not easy to keep the logs of all those queries. So most people don't, but if they do, then they'll go through them forensically. But no one looks at normal day-to-day DNS to see what's happening. Maybe they should.
Yeah, absolutely.
And you kind of, touched on it before, it's the ability, isn't it, to spot these things really early in an attack chain as well. So if it's a cybersecurity incident, the idea, you kind of touched on the idea of known command and control system. So if you know it's a command and control domain somewhere, if you start to see DNS requests and DNS traffic being, requesting access to that domain, well, straight away you're seeing that, but you're seeing that so early. You're not seeing that once the malware's kicked in and started doing something wrong. You'll see maybe even an initial request that says from the malware that's been deployed, hello, command and control, I'm here. And now I'm going to shut up. I'm just going to do that initial request. I'm active, and now I'm just going to shut up for 3 weeks until we kick in, so that even if I've been spotted being deployed, I'm not necessarily being spotted doing anything else. But actually, from a DNS point of view, you're going to see that kind of very first request that goes, well, we can do something with that. But you also talked to me about some kind of more proactive stuff that you could be doing here as well, not just spotting that kind of thing.
So a lot of people talk about zero trust as a concept now. That I don't meet customers very often that don't have that at the top of one of their lists of things to do. And it is just a change in how people look at security from the old kind of perimeter security of if you walked in a building and you were allowed to be in the building, then you could open any door you wanted and you could do anything you wanted because you were trusted.
Yeah.
Right. And then zero trust just flips it. And it doesn't matter who you are, where you are. You've always got to continually prove who you are and that you're allowed to do something. And that works great as a concept. And there are platforms that will look at you all the time and say, okay, Paul, can you access this application? Well, no, you can't. So you're not getting access, which is fine. But no one looks at the DNS aspects of it. And if you look at an internal name server that's hosting the internal names, so if I want to go to finance.efficientip.com, there might be a name for that in our DNS on the internal side. Should I be allowed to query that if I'm not allowed access to the system? Because by default, I would imagine in most companies, if you make a legitimate query for a name that's in an internal zone, and that is being there's a DNS server that's authoritative for that on the network that you're on, it will answer your query.
Yeah.
And I don't think it should.
Yeah.
And there's a number of use cases around this. There's the one where you as an individual might not have or be allowed to see certain systems within the network. But if you had an infection on your laptop that you picked up, say, in Starbucks one morning, not that Starbucks is a place to go and get malware, but just on the off chance, the first thing it's going to do, because it's probably not targeting Paul's laptop, it's wanting to target something in the organization. So it's going to try and move laterally. And it will start doing reconnaissance. If it's got the ability to, it will go and look at ARP tables to see what IPs are around, all that kind of thing. But it might start making DNS queries just to check what names are available. And if it gets a response, if the DNS server responds to a request for an A record for finance.efficientip.com, 2 bits of information have now been known. One is that name is valid. And 2, you know the IP address on the internal network. You may not be able to access it, but that could be a target.
Yeah, it's a starting point.
It's a start point.
Yeah.
And that information wasn't known 2 seconds ago until that query was made. And in a zero trust world, should that be allowed? I don't think it should. So we have a way with Efficient IP where we can start to, at a granular level, control whether a client has access to be able to look up valid names. So not just the threat actors that you can buy the commercial feeds for, but internal names. So can I see the finance systems? No, can't query them, can't access them. And we were talking earlier about IoT and OT devices, right? So a lot of these, they get put on the network. They're normally manufactured in bulk, so it's very cheap to develop. Yeah. Management's normally an afterthought, but they probably do maybe 1, 2, 3 queries. You know, a camera probably needs to know where it's going to send its video. Might want a management system if it needs any updates. Thermostat obviously has to talk to a boiler, all those kind of things. But they shouldn't be going anywhere else. So if you can just restrict IoT, OT devices, and whether it's a camera, it's got some names it can talk to. Thermostat has different names. Door entry, again, another set of systems that they can access. If you just restrict it down to the queries that those devices are allowed to make and flag up any that aren't, and you can still respond, you can give the answer back just in case it needs it, but it's getting that visibility of, hey, this is a potentially anomalous event. You know, does someone want to look at it?
Well, it's adding kind of another layer as well, isn't it? Because I was thinking while he was describing it, you know, some people might be watching this and saying, well, I can do that separation. Yeah, I can start to VLAN things off. I can put firewalls in front of things and say, so while, you know, using that finance example, while I might be able to find finance, I can't actually get to it. Yeah. But as you said, you know, it's not so much about that. It's now something that somebody can go and target. So it's the idea that, well, yes, I can firewall off my OT devices, for example, or VLAN out the OT devices. But that doesn't mean that OT device then, if we're allowing DNS, which we probably are, doesn't mean that OT device couldn't be compromised and is now sending data somewhere that it shouldn't. Yeah, if we start to limit it to say, well, actually, as a device, you should only be able to see these 3 things. Every other request you make, you're not going to get a response to, and I'm going to make you ineffective. And it's like with the other example, while you're doing reconnaissance, the minute you can find servers that might be of interest, doesn't matter whether you can get to them, you're sending that information back and saying, well, our next attack needs to be that VLAN over there. How do we get onto that? But if they don't know that that thing exists in the first place, you know, it feels like a really nice way of layering up that security, using DNS as kind of one of those fundamental points of all communication is going to start there somewhere. Yeah, is actually, well, if we can stop it there and stop the threat there
and get visibility of it.
Yeah, absolutely.
Yeah, it's brilliant. It adds telemetry where it would otherwise be missed.
Yeah,
you know,
it's a great point.
When we talk about networks, you know, when I know a lot of people assume we're talking about PCs and servers and stuff like that, but actually, IoT devices, printers. You know, when was the last time anyone looked at what a printer was actually doing on a network? You know, normally it's has the printer got an IP
printing
address?
Is what it's doing. Yeah.
I've seen one printer that's any ping on the network it responded to.
I thought you were going to say you've seen a printer on a network that actually printed.
Yeah. Well, certainly not in my house.
Yeah. But it's a good point though, isn't it? Because most organizations, not most organizations, but I would say a lot of organizations don't patch those devices as frequently as they should be. You know, printers go on a network, they work, they don't get firmware updated every time it comes out. They may be old, they may have vulnerabilities in them. But no one's looking at that device. And so that device is a perfect jump off point for someone being in your network, compromise the network from that device. The first thing that they're going to do is run some kind of Nmap scan. What can I see on the network? What can I learn about this network? And because that device isn't following the normal channels or getting any kind of visibility under it, the attackers can stay in the network and they can live in the network for, 6 months in some cases. I think it's a dwell time of about 42 days at the moment, where attacker gets in, sits there building up intel on your internal network before anything happens. The first thing that's going to happen when we're doing Nmap, as you've just described there, is we're going to scan for devices that we're going to learn about the network, right? We're going to do some kind of reconnaissance. And if we can lock it down, that's perfect. That gives so much visibility. I mean, we speak quite a lot about, if you want to improve your cybersecurity, increase your visibility. This is a great way of doing it.
I think we're sold.
Yes.
Let's have some. Let's have some security.
Client query filtering, that's what we call it. I mean, it is one of those things. I was in the military years ago, and you could get classifications going up depending on what your vetting was, and it went from kind of restricted, classified, secret, top secret.
Yeah.
So you could be cleared for a particular level, but that didn't mean you could access everything that was classified as, say, secret. You still had to have a need to know what was in the document.
Yeah.
And if you didn't have the need to know, you weren't allowed to see that. So why don't we treat DNS in a similar way? Some names you only want some people to be able to access.
Absolutely. So anyone listening wants to find out more, where's the best place for them to go?
So you can come to our website, www.efficientip.com. We have a system where we can, within about 5 minutes, on a WebEx, do it in person, where we can show whether you're vulnerable to exfiltration using DNS within the network. It's a really simple test to do. You can register it through the website. Literally, it's 5 minutes to do it. We can do it online. You can do it through a web browser. You don't even need us there when customers do it. And it just shows whether or not you're susceptible to exfiltration of data over DNS. If you are, then it's a conversation to have. There's a couple of outcomes where either the domain's being blocked, which is okay, but the best one is if you see a few queries come through and then it stops. That generally means that customer has decent DNS security in place. And it's normally a good checkpoint. If they see that, it's just a reaffirmation that they've actually got a reasonable solution in place. Okay, the conversation on DNS security doesn't go any further with us at that point, but the customer gets a little bit of confidence that they're still covered and it works.
Absolutely, that's great.
Yeah, sounds great. I think the idea that and actually we'll try and make sure we put links to that in the show notes, because I think that you don't know what you don't know a lot of the time, and actually something as simple as that for people listening to this, give yourself listen to the end. Once the end has come, you've got 5 minutes to go and find out how secure your DNS services are. So, but I think that's great. So and
it really is. It's 5 minutes. Maybe we get a conversation out of it after if you are susceptible. If not, you get reaffirmation that you're okay. It's worth doing it, I think.
Yeah, that's great.
Absolutely. I think DNS security, I'd say it's one of my favorite topics. I think you can apply DNS security, relatively low cost, relatively low risk, low impact, for lots and lots of value. So, I think it's absolutely something that people need to explore properly. Yeah,
definitely. Peter, thank you very much.
Thank you for having me.
Thank you very much.
Hey, pleasure. What else am I going to do?
We hope you've enjoyed this episode. Check out the show notes below. Hit the subscribe button on the way, but check out the show notes below. If you want to run that IP scan, the DNS scan, and you're not sure how to run it, get in touch with us. We'll help you run that scan, check your network. So we're available in all good homes of podcasts. See you next week.